Hello, this is Ian Vogelesang, and this is the video for Demo to create Rollup. I'm going to show you the RAID version because the DF version is a subset of the RAID version of Create Rollup, so let's take a look at that. Let's take a look at the IvyScript program used for this demo. And at the top we have a host statement. We create a couple of workloads with the same name on different LDEVs and different ports. And we use an edit rollup to set the parameters for those workloads that we just created. And so far it's been the same as the previous demo. And here we can see a create rollup statement. The thing that you create a rollup on is an attribute such as port. Generally speaking, rollups are created for a single attribute. But if you've got more than one subsystem in your test configuration, you can create a rollup on a combination of attributes. In this case, we can say, let's create a rollup on serial number plus port. So if you have multiple subsystems, you can distinguish between the ports that are on the different subsystems. If you create up a rollup on host, the word host by itself in Ivy means the name that you used for the host on the host statement, the IvyScript host name. And that may be an alias, or it may be the canonical host name, or it may be an IPv4 dotted quad. Okay. Then here we're creating a workload on an attribute that was discovered using a command device. So we say create rollup MPU. And then what we're going to do in a moment is we're going to look in the CSV files and we're going to see that the subsystem data gets filtered by MPU as well. Then if you want to see CSV files for absolutely every single individual workload that's running, you can either say create rollup host plus lun name plus workload, and the workload part of this is the name that you gave it on the create rollup statement, which in this case is study. The lun name is /dev/scxx, and then host is the IvyScript host name. Oh, and then down here we can see an IvyScript programming language statement that calls a built-in function called show rollup structure. And here we'll see the output from that. So you can see what's in your various rollups. And then we just run a step where we run for warm up for one subinterval, 5 seconds, and then we run for 5 seconds. The idea really is to see the rollup structure. So if we close this and look at the output folder for this IvyScript run, we can see that we have a command device because we've got the subsystem configuration folder. And then you can see that you've got folders for each one of the rollups. If we look in the MPU folder, we can see a number of files in here. There are summary CSV files for each of the rollup instances. So there are 4 MPU instances, and in these rollup instance summary CSV files, you get one output CSV file line for each test step for each subinterval sequence, and that one CSV file line will summarize what happened in the measurement subintervals in that test step. But you also get an overall rollup CSV file that contains the lines in each of the individual ones. So if in the summary.csv file here for the MPU rollup, you get 4 lines for every test step, which are the 4 lines that are in these CSV files. So let's go ahead and look at one of those. So if we look at this CSV file, we can see here that the rollup type is MPU, that the rollup instance is MPU number 1. Since we have a command device, we get the columns showing us what drive types are in use and how many of them there are. But if we look at, if we go over a bit here and look at the filtered subsystem performance data, so in these columns here, you're looking at data that's filtered by the rollup instance. And in particular, okay, let's look at For subsystem MP core count, you can see that there are 4 cores. And if we look at one of the other CSV files, let's look at the all rollup, for example. If we look at the all rollup, we'll see, hopefully, that we've got 16 MP cores. Yes. So here you can see that the MP core count for the all rollup is 16, but that for the MPU equals 1 rollup, we get 4 cores. So this illustrates the fact that the subsystem performance data in these columns is filtered by rollup instance. Okay, then, we're going to look at this one is the overall summary CSV file for the MPU rollup, and you can see here that for step 0 we got 4 output lines, the 4 output lines in each of the individual CSV files. So I found practicing with IV that I needed to add this for some of the cases to print the graphs and charts for the things that you're interested in. Okay, that was pretty much what I wanted to show you for Create Rollup. There was one other thing I was going to show you, and that was the rollup structure. So if we go to the logs and we look at the log for IV Master, and we take a look at the log file of running the IVScript program, and scroll down here. So this is the beginning. We've got all discovered LUNs, so these are all the LUNs that we discovered on all the test hosts. These are the command devices. And here we're connecting to the command device and we're retrieving configuration. And then after that's done, here's the configuration thumbnail after we got the configuration information from the array. And then after adding subsystem configuration attributes, there's it shows you in the log file here what available test LUNs there were with both the SCSI inquiry as well as the RMLive API attributes. Here's the log file showing us creating the workload threads, and here's where we're setting the parameters in those workload threads. Here's where we're creating the rollups, and then we get to the statement in the IVScript program which prints the rollup structure. So we can see that there's a rollup called all that has 1 instance. This 1 instance all has 4 workload threads in it. Each workload thread has a workload ID comprised of the IVScript host name, the /dev name of the LUN, and the workload name. We can see that the host rollup has 1 instance and it has 4 workload threads in it. We can see that host plus LUN name plus workload, that rollup, has 4 instances, each which have 1 workload thread in that rollup instance. We can see that MPU has 4 instances and each one of these has 1 workload thread in it. We can see that parity group has 1 instance, 1-1, and it has 4 workload threads in it. And we can see that the port rollup has 2 instances. The 3C instance has 2 workload threads, and the 4C instance has 2 workload threads. We can see serial number plus port. We can see that the rollup instance name has the subsystem serial number plus the port name. And then workload ID is a synonym for host plus LUN name plus workload. So that's it. And then here we can see a couple of subintervals running. This is what scrolls up on your screen. You'll notice when you're running IV that it displays messages as it goes along that shows you where it is in the test and how things are going. It kind of gives you like a progress bar in real time. Okay, that's the end of Demo 2 Create Rollup.